My name is Paul Schnackenberg. I'm originally from Sweden. I've been in Australia for about 20 years. I work part-time as a teacher. I also run my own business as an IT consultant. So a couple of housekeeping items. I'm really happy to take questions during the session, because I hate going to sessions where they tell you at the beginning that you have to hold on to your questions till the end, and then you've forgotten what you wanted to ask. So I'm happy to take questions during the session. Now, obviously, if something turns into a longer discussion, then we'll sort of park that. I will be available directly after this session up here until the next speaker kicks me out, and then I'll stand outside. So you won't miss out. I will definitely answer all your questions, even if they're a bit longer. And otherwise, we can make a time and have a chat in the speaker lounge or something like that. I've got stickers. So these are moderately funny if you're in the least bit interested in security. I don't know whether you can read that, but pass the hash is quite common in ways of hacking into systems. Golden ticket. How many people have heard of the golden ticket? Oh my God. One hand? Two hands? Oh, okay. This is not a security talk, but I assume that most people would know what that is. Okay, if you don't know what a golden ticket is, you need to go up and read about this. Basically what this means is that a hacker who gets access to your Active Directory can make a ticket that lets them be anyone, anywhere on any system in your entire forest. That's a golden ticket. And so I should ask then, of course, does anybody know, who knows what pass the hash is? That's better. Okay, that's about half or just under half. The rest of you go up and read about pass the hash, all right? So there's 2 white papers from Microsoft, and I haven't even got to VMM yet. There's 2 white papers from Microsoft that talks about defending against passing the hash. It is a very serious attack on your network. My other PC is Azure, and keep calm and put it in Azure. So I got a whole bunch of these stickers, but you get those for asking good questions. Right, so I mentioned I'm from Sweden, so before we head into the content, I wanted to see how much you people know about Sweden. First person to answer this correctly for a set of 4 stickers. Come on, you can guess. Lego. Somebody said Lego over here. I think there was Lego over there. You get the stickers. So Lego is Danish. All the others are Swedish, although I suppose I think Volvo now has been bought by the Chinese or something like that, but they're still made in Sweden. So there you go. Right. So here's the agenda. So the topic is a long one. It's about software-defined and virtual machine manager and how you can use that. So I'm going to start off by giving you a quick definition of what software-defined is as far as a data center goes. Then I'm going to talk about virtual machine manager. So first question up here, how many people are running virtual machine manager, any version in production? So that's a little bit over half. So we turn the question around. How many people don't know almost anything about Virtual Machine Manager? So there's a few hands going up. Okay, so for those of you who put up your hand, I'll cover it very, very briefly. Then we're going to look at 6 major features, right? So I won't have time to go into the underlying technology of those features. I will simply talk about what VMM can give you. A few, I will deep dive a little bit into storage spaces and software-defined networking. Does anybody feel there's anything missing on the list they would like me to talk about while we're looking at VMM? No, that sounds good. All right, so software-defined. So I'm a sort of a hands-on guy. I've been in IT for a long time. And I don't like these marketing terms, right? That sounds very airy-fairy. So private cloud, you build your stuff on premises. What does software-defined mean? Well, this is all about how do you go from the way that we've traditionally have run our data centers, right? Which is you have a mix of hardware from different vendors, right? So the classic one that I see is you have a SAN from this vendor, then you have another SAN from this vendor, and then you have a third SAN from that vendor, or you got some networking gear from different vendors. And each of these have to be managed using a proprietary interface, right? You want to provision some more storage over in that SAN. Well, you gotta go to that portal to do that, and you gotta know how to do that for that tool, right? Et cetera, et cetera. And that becomes very inefficient long term. And then we have there's a lot of manual management, right? Automating this mix of different hardware and software, et cetera, becomes very difficult. And it's people-centric, right? So how many people went to George's, the Premier Field Engineering Automation talk last night? So that's about a quarter. So he was talking about exactly about this, how a lot of very well-skilled, experienced IT professionals end up doing a lot of very mundane work, right? He was talking about people spending like 6 months of a year. That's all they did was patching machines, right? I think it was patching SQL servers. That's not a good job, right? That's not really going to give you long-term job satisfaction, spending half of your time every year at work just patching SQL servers. So you want to move to something that is more automated. And the reason for this, of course, is that, and this is a reality, I'm an IT guy like you, we now have competition from the cloud, right? That's what it's all about, because that's how the big hyperscale clouds like Azure and Amazon, that's how they run their infrastructures, right? They don't do any of that stuff there. They do this, right? And because they do that, they can be very efficient and they can sell you virtual machines really cheaply. And so you need to follow suit, at least to some degree. So you want to see if you can get to a place where infrastructure is code. I'll get to that when I talk about software-defined networking, but the lowest or medium, at least, hanging fruit here is the networking space, because that's a very complex thing. How many people in the audience would call themselves networking guys? I'm the networking guy. There you go. There's one hand. So 2 hands. So you want to see if you can and move beyond that using software-defined networking. And we also talk about software-defined storage. So those are things where VMM can help you. Any questions on any of that? All cool? Excellent. So Virtual Machine Manager 2016. So for those few of you who put up your hands, haven't heard about Virtual Machine Manager, so this is a part of System Center. I think the first version was 2007. I've been involved ever since the first version. And in the beginning, it literally was managing virtual machines, right? But over the years, and certainly in this latest version that came out in October, November, we're talking about managing your whole data center, right? So it manages your storage, your networking, your load balancer. If you've got hardware, load balancer can be managed with VMM, and all of that stuff. It also provisions your data center fabric. So if you've got 8 new servers rolling in, bare metal servers rolling into your data center, you can use VMM to deploy to that. So put your hypervisors or your storage servers on there. And once you've got your fabric up and running, you can then deploy multi-tier applications. So just like you can go to Azure and you can say, I want 2 web front ends and a middle tier, and I want a couple of database back-end servers, and put that into an ARM template. Can I please spin that up in Azure? And then 15 minutes later, you got all that set up. You can do the same thing with Virtual Machine Manager. Unfortunately, it doesn't use ARM templates, but it's there. And then you can put a cloud on top of that, so you can then offer that out to your end users. So of all of those who put up your hand that you're using VMM in production, how many people actually have created a cloud inside of VMM? So that is less hands, right? And that's also my experience. Lots of people use Virtual Machine Manager to manage the fabric, but they don't put that extra cloud layer on top, right? And it's literally make cloud and little button that looks like a cloud, and you press that button, and now you put an abstraction on top of VMM, and you can present that out to particular people in your organization. Now, you don't want Jane, the receptionist, to go, hey, it's Monday morning, I think I'll spin up a VM, right? That's not what you want to do. What you want to do is you want to maybe give your developers the way to create virtual machines easily, right? Okay, so here's a fabric view. It manages your compute. It does both Hyper-V and ESX. If anybody was ever using Xen together with VMM, that's now gone in the 2016 version. It manages your SAN, your NASes, your server message block, file shares, storage spaces direct. and then your networking, load balancing, MAC pools, IP pools, etc. And then for your virtual machines, we can create templates for them, we can spin them up, we can move them around in our fabric, we can migrate from Hyper-V to, from VMware to Hyper-V. If you've got physical machines and you want to put them into VMM, you can no longer do a physical to virtual conversion in VMM 2016. That feature has been dropped between 2012 R2 and 2016. There is a standalone tool from Microsoft, which basically uses the same technology underneath, called the Microsoft Virtual Machine Converter tool. That one is also being end-of-life. So if you've got a bunch of physical servers in the corner in your data center and you're going, we should probably virtualize those, but I've left that, you want to go at least and download this tool. The version is 3.0. It's an excellent tool, but as I said, it won't be available from mid-year, I think. So it supports 25,000 VMs on 1,000 hosts. All right, so for those of you who said that you're running VMM in production, so how many people have more than 10 hosts that you manage? 20, 40, 60, 100. The little hand goes down. So I think so. How many of you got? So 106. And you? 140. Okay, so 140 is the winner. You can come up and get some stickers later on. I've got too many stickers. You can also do some basic management. You can see your AWS and Azure VMs in the interface, and you can turn them on and off. That's about what you can do. All right, so some real-world things here that you need to be aware of with VMM. So because the quarterly update cycle, there's an update roll-up every quarter for System Center overall, including Virtual Machine Manager. The new features, VMM has got some love in this new version, but it's not like we've been waiting for 3 years since the last version to get all these new features. Some of these things have come along the way in 2012 R2. And there's also no major architectural changes. So if you have a requirement to do high availability for your VMM implementation, it's still an active passive clustering, right? So you spin up 2 Virtual Machine Manager instances, one is active, and you store the encryption keys in Active Directory. And if you're going to do that, you want to have a talk to your SQL DBAs because you want to look at high availability for the SQL Server backend. SQL Server 2016 is now supported in VMM 2016 as well. So there's some I'm not a SQL guy, but I think there's some new high availability stuff in there. And if you have multiple sites, so if you manage multiple data centers with VMM, and you have separate VMM installations in these locations, you need to synchronize the library. So the library is all the scripts and templates and VHDs and everything else that VMM keeps track of. And you got to synchronize that between the locations, right? And there is still no inbox tool to do that in VMM. All right. So feature number 1 that we get from Hyper-V is, right, and clustering in general between 2012 R2 and 2016. So Microsoft has made it a lot easier to upgrade clusters. So how many people know about rolling cluster upgrades? That's almost everybody, right? So Microsoft has talked a lot about this. For those of you who don't know, here's how it works. Before that, I've got a couple of little jokes in here. So everybody, I'm assuming, has heard about cows, not pets, the DevOps concept, right? You should just treat your servers as replaceable, and if there's a problem with it, you just delete it and create a new one. So I have really taken that on, and I've done that with all my client servers. I treat them all like cows. It's just that they're sacred cows, so you can't touch them. So... All right, so upgrading from 2012 R2 to 2016. So I've got a 4-node cluster here. This is Hyper-V, but it could be any cluster. I live migrate my VMs off it. Right? I evict the node out of the cluster. I blow it away, and I install Windows Server 2016 on it in a clean installation. I put it back into the cluster, right? So this is this mixed version cluster. So for all of those of you who've done an Active Directory upgrade, you know that you can add the new version in as a domain controller, and the old versions talk to it and thinks that it's an old version domain controller. And then eventually, once you've upgraded all your domain controller, you can then upgrade the domain and forest functional level, right? So this works exactly the same way now in clustering. So we've done node number 1. So rinse and repeat, live migrate VMs back onto that node so that node number 2 is empty, or 3, I suppose it is, if you count them from the left. And eventually rinse and repeat for all of them. Now they're all there. And then finally, once you know that you don't have any more and you're not going to add any 2012 R2 cluster nodes, you upgrade the cluster functional level and you unlock the new features that Hyper-V brings in 2016. Now, that's a lot of work, right? Even for a 4-node cluster, if you're going to do that manually using, failover cluster manager and Hyper-V manager, that's a fair bit of work. So VMM does all this for you. It's got an orchestration engine that does the entire workflow for you, and it is zero downtime for your workloads because they are live migrated from host to host. So I thought I'd demo that for you very briefly. So we swap over. And there we are. Now, I tried to lower my screen resolution so that that would be visible to everybody. Can the people back in the back of the room, can you see that? Excellent. All right, so here I've got a VMM 2016. We can get rid of that. So what do I need for this? I need a physical computer profile. So in this case, I've got a Dell server here. And that physical computer profile has some settings for the physical hardware. I also need in my fabric to have a PXE server. So in this case, I've got a PXE server there. And I can grab my Windows 2012 R2 cluster here and simply say upgrade cluster. Now you get an option here, and this is obviously a 2-node cluster, so that doesn't really apply. But if you had like a 16-node cluster or something, you can pick a couple of nodes. If you're not quite sure and you don't want to go sort of the full hog straight away, you can pick a couple of nodes just out of your bigger cluster and just upgrade those and make sure that that all worked and check it. And once you feel comfortable with that, you can move on to the next part of the process. I'm going to pick my Dell physical computer profile there. And I've got to pick a BMC run account. So BMC is my baseboard management controller. So Dell calls them iDRAC. HP calls them ILO, Lenovo calls them something else, but the idea that you can talk to a physical machine before it's got an operating system on it, or see BIOS upgrades and that sort of stuff. You can pick 2 different protocols, IPMI and Smash. Turns out that if you have Dell servers, they do IPMI, but you've got to go and turn it on, and if you haven't turned it on in the UEFI, it doesn't actually do it. And then you go to deployment customization. So it goes out, talks to these machines. Now, because these have not been deployed with the BMC setup originally, I've got to tell VMM what those, don't try to type and talk at the same time, what those settings are. And now if I hit next here, it would just go on, reboot those hosts, or live migrate the VMs off, reboot one host, take it out of the cluster, reboot one host, and put Windows Server 2016 on it, and then add it back into the cluster and do what we saw on the slides before. Okay, any questions on that? Yes? Where does it get the OS image from? So I've got to add an OS image in, right? So I've got to add and I'm coming to bare metal deployment in a minute, and I've got to add that in. Yeah. Any other questions? Excellent. All right, so we swap back. Should know those off by heart. And that, of course, would take hours, so I'm not going to do it here. All right, so Nano Server. So you're going to get sore arms. How many people have heard of Nano Server? I think that would be almost everybody, right? If you have managed not to hear about Nano Server so far, basically Windows Server 2016 comes in 3 flavors. You got your server with a desktop, server with a GUI or whatever you want to call it, or whatever they call it this week. And then you have Server Core, which has no GUI, but it's got your command line interface, and you can log on to it. And we've had those since 2008. And then you've got this new version, which is Nano Server. So this one, you got to treat very differently and manage very differently, right? Now, fortunately, VMM has full support for this guy all the way. So because Nano Server is an excellent container host, I thought this quote was quite nice. The world is being eaten by software is probably true, I think. Or even companies that never considered themselves tech companies now have to use technology to compete. So I'm sure you've seen something similar to this slide, right? So you got this just enough OS, where Nano Server is the most scaled down version of Windows you can ever get. It has an incredibly minimal emergency management console, and that's the only local GUI you've got. There's nothing else. Now, as far as VMM is concerned, a Nano server can be a Hyper-V host or a storage host if you put it onto physical hardware. And of course, you can run Nano server as a VM, right, so to run your applications on top of, provided they run on Nano server. Okay, so unlike Windows Server, you can't just sort of install Nano Server, right? It's not one of the options when you run setup off a DVD. You actually got to build your image. These are the packages that you need to add in for a host server, a physical host server in Nano Server. Now, of course, there is a Nano Server image generator that Microsoft gives you, which is all PowerShell, right? And for those of you, or those of us who are not that that friendly with PowerShell, you know, I get by, but I'm not an expert. There's a Nano Server image builder, which gives you a nice little GUI on top of that generator, and you tick boxes, and then you press, and then you end up with a VHDX or a VHD in the end with Nano Server on it. So that's an image of this free tool. And you can just download that and run that. And here I'm on the slide where I'm picking what packages I should add in. And earlier on here I picked whether I was creating an image, a Nano Server image for a physical server or for a virtual machine. Right. So let's talk about real-world Nano Server and real-world bare metal deployment in general. So bare metal deployment in Virtual Machine Manager has been there since 2012, right? The concept is you have a WDS, a Windows Deployment Services server, somewhere in your environment. You can use your existing one. You don't have to have a separate one for VMM. This just shunts any images that VMM wants to deploy over to VMM. And you need to have an image, of course, to go onto the servers. It was very, very, very challenging in 2012 to get this to work. 2012 R2 made it a little bit better because we got a deep scan. So the servers get a message from VMM to the baseboard management controller. They reboot. They boot WinPE, and WinPE goes in and does a hardware scan, right, just as it would when it was installing on the physical machine. That hardware information is fed back into VMM, and you can then make choices and make sure you got all the drivers, etc., in place. In my experience, though, this is quite challenging to get right. It's a little bit better in 2016 because there's a lot more drivers in the box. So you get, you have less drivers to inject into your custom image to make this work. And of course, Nano Server has no local GUI and no local command line interface, which means that if there is any troubleshooting to be done, especially network troubleshooting, you have a fairly challenging time ahead of you. So here's a good question, right? Whenever I talk to guys who run Hyper-V, we all seem to run it on the full GUI, right? Even though Microsoft's recommendation has been to run on Server Core since they made Server Core. So again, you're going to have to exercise your arm. So out of those of you who said you run Windows Server VMM in production, and I'm assuming with Hyper-V, how many of you run on the full GUI? All right. And how many run on Server Core? Oh, wow, that's pretty cool. A few of you have gone through and made that. So those of you who've gone through the work of getting it to work on Server Core, you'd probably be right with Nano Server. For the rest of us, you want to troubleshoot, you've got a nice GUI there. All right, so let's have a look at this. So some of these things take quite a long time in VMM, so I've got some videos to show you on how to do this. So here is managing a Nano Server physical host. So I'm in VMM, I go into my fabric, I go into all hosts. So I've prepared this image and deployed it to a physical machine using outside of VMM. And now I can go in and add it into VMM, pick my run as account. So this is very similar. Don't look, that was domain admin. Obviously, you don't have a run as account called domain admin in your production environment. And I just give it the computer name that I need to add in there. It goes out, finds the domain join machine in Active Directory in this case, and it tells you that I'm going to add the Hyper-V role if it's not on there, but that doesn't count for Nano Server, of course, because Nano Server, you've got to add it before you deploy the machine in the first place. And off it goes and adds the machine in and picks up the VMM agent that you put on there when you created the Nano server image, right? Whereas with a normal Windows server, it would deploy the Nano server, the VMM server agent onto that server automatically. And there it is, tells me it doesn't have multipath I/O, but other than that, it's enabled. All right, any questions on any of that? Cool, and then of course, deploying a Nano server VM. So here I've added in a VHDX file with a Nano server. It reports that it's 6 gigabytes, I think, but that's the maximum size the disk can grow to. It takes just over 500 megabytes, so that is a full Windows server, Nano server. So I picked that, I'm creating a template here, and as you can see, this experience is exactly like any other template experience that you do in VMM, right? So once you've got that VHD, VHDX that you create outside of VMM, you put it into VMM, the template experience is exactly the same. And there's my template created, that takes a minute, and then I go in to create a virtual machine, and I pick my template, and I configure, again, exactly the same as any other machine. We'll talk about shielding there in a minute once we get to that portion of the talk. Which host am I going to deploy it to? That's the intelligent placement for those of you who haven't seen VMM. It figures out which host is the best one given all the load on all the other hosts to run this VM on. I pick my network adapter I'm going to add it to, any other properties, and I'm going to start the virtual machine after I've deployed it. And I think at the end here I show you the GUI that you get with or at least a login prompt, right? So there's my VM running on top of a host, and if I go in and do a console connection to it, I get the basic login prompt. And if I logged in here and went to the next screen, there's a little bit of resetting the network and resetting WMI, and that's about it. All right, any questions on any of that? That's all cool? So that's Nano server. So the college where I teach part-time, we actually got given new servers literally like 3 weeks ago, so it was very good timing. So I thought, oh, I'll put VMM through its paces here and deploy to these guys. So these are the machines they got. That's a Dell server we're unpacking there. So notice that we made sure that they came with TPM 2.0 chips, right? So that we can use shielded virtual machines. We'll get to that in a little bit. And I've picked hard drives. I actually made a mistake here for Storage Spaces Direct, right? So we're going to use, we don't have a separate storage for these. They're going to use internal storage in each machine. I'll get to Storage Spaces in a little bit. But I should have had, since I have 2 SSDs, I should have had 2 or 4 or 6 hard drives. So you want to match that up in increments. So if I had 3 SSDs, I should have had 3 or 6 or 9 hard drives, right? So that was a little mistake, but don't know everything. So there you go, 4 servers racked, stacked, and ready to go. So here's a bare metal deployment. In this case, I'm using the full GUI image, but I could have used the Nano server image. So I've got a physical computer profile here. I'm creating a Dell R7XD. I pick my image that I'm going to deploy to, and make sure that if you're using UEFI, which you have to for shielded virtual machines, make sure you pick GPT there and not MBR disks. Mistake I made. Took me a while to figure out. Add it to a domain, give it a local admin password, any other settings that we want to put in. There's the host guardian service. We'll come back to that when we talk about shielded virtual machines. And once I've created the profile, I then go in to add resources in the fabric and pick my Dell iDRAC account, my IPMI that I've now turned on. It goes out, finds the bare metal baseboard management controller on each host, and then I go in, set the settings, right? What am I going to call the server? Which drive am I going to deploy the operating system to? And all the other drives are left alone because they're going to go into Storage Spaces Direct. Right. So I've mentioned it several times already, so let's talk about Storage Spaces Direct. So storage spaces was introduced in Server 2012. This was Microsoft's first foray into software-defined storage, right? And the idea here is that there is always the right storage for your business somewhere that gives you the performance and the capacity that you need, and it is always too expensive for you, right? So what Microsoft was looking at was coming up with a way to use Windows Server to give you the storage without involving SANs. I mean, they didn't quite put it that way, but that's what they were doing. So storage spaces is a great solution. If you have a medium to large environment, you put a bunch of file servers, 3 or 4, in front of some shared disk trays. You stick some SSDs and some hard drives into those disk trays, and that storage is then all pulled together, and it's shared out, and it's just ordinary file shares. Your Hyper-V hosts over here, they all talk to that shared storage, and you get great performance because you got the tiering, you get RDMA networking in between, so you get the fast speed. You know, you can go to 40 gigabit or even 100 gigabit, and that certainly competes with fiber channel. But it really only worked for medium to large environments, right? It had to make sense to have 2 or 3 separate servers just for that, and then have the storage behind them, and have the SAS trays and connect everything up. So Server 2016, and I know there's other presenters, and there is a talk at 5 o'clock today about where Stefan goes in depth into storage spaces direct, so he's going to cover this a lot more than I'm doing. In Server 16, we now get storage spaces direct. So you put the storage inside of the physical servers. So this gives you a lot more flexibility. You can now use SATA drives and SATA SSDs. You can use NVMe memory, which is your SSDs connected directly to your PCI Express bus, right, which gives you fantastic performance. And those things are not normally shareable, but because we put them inside of the servers, you get the performance. And you can do this in 2 ways. So again, if you have that medium to large environment, you can do your storage disaggregated, right? So here we have servers separately, and here we have the hyper-converged option. So of course, I think everybody has heard about hyper-converged. This is sort of the buzzword of at least last year. So the concept here is that your Hyper-V hosts are also your storage hosts, right? So internal storage in this case 4 hosts is all pulled together. Your VMs are stored in several copies on each of these Hyper-V hosts, and then each Hyper-V host runs a certain number of VMs, and you can live migrate them around. Any questions around those concepts? And I should point out here as well, you can go, so the lowest amount of storage nodes you can have is 2 in Storage Spaces Direct, and the largest is 16. Now, with 2 nodes, you get 2-way mirroring, right? So it stores 2 copies of your data, 1 in each location, or 1 on each server. That's great, and that gives you, a single disk failure protection or a single host failure, right? One host fails, the other one keeps on running. But you've got to pay twice as much for your storage, right? So if you want 10 terabytes of storage, you've got to buy 20, put 10 in each server. With 3 nodes, you get 3-way mirroring. And that gives you great performance, because mirroring is really fast, but not very good disk utilization, right? So if you want 10 terabyte, you've got to buy 30 terabytes and put that into, combined with SSDs and hard drives in each host. Once you get to 4 nodes, and I'm sure Stefan will cover this in more detail, you get something that is really, really cool. And this is magic. What Microsoft has done here, to me, I'm a tech geek, but I think this is really cool. So you can do parity, which is a great way of storing data, and it's very space efficient. But the problem is that parity is really slow at writing, right? Which, especially random writing, which really sucks, because VMs do a lot of random writing as far as the storage goes, right? So what you want to do here is you really want the efficiency of parity, but the speed of mirroring. Well, they've done that. They put it together on the same volume. So in storage spaces, if you've got 4 or more nodes, which is why I got my college to buy 4 nodes, you can combine parity and mirroring on the same volume, right? So you set aside about 10 to 15% of the drive as mirroring, and that takes all the incoming writes really fast, because you could just write it to the drives, 3 copies, done, right? And then when it's got the time, it then writes it out to the parity space. So you get about 60 to 65, 70%, depending on how many nodes you've got, even up to 80% disk utilization, right? So I'll do the maths in my head. If you want 10 terabytes, you buy 16 terabytes. I think that's about it. Then you get the disk utilization that you would like, right? So that's really cool. All right, so here we have a disaggregated setup. So here's what you do in VMM. You simply tick this box, storage attached directly to each cluster node, storage space is direct, right? So that's creating a disaggregated cluster. And then you present that out as file shares, right? Using virtual disks, etc. And if you want to go the hyper-converged option, you have your 6 nodes in this case with internal disks. And when you create your storage spaces, your storage cluster, you just say enable storage spaces direct. And VMM will go out and pick all the drives that have no partitions on them, right? If you put a partition on it, VMM and storage spaces direct just in Windows Server as well, assumes that there's data there and I'm not going to blow it away for you, so I'm not going to use those disks, right? So you want to leave them empty. And then you stick your virtual machines directly onto the cluster shared storage. Any questions on any of that? That's all cool? So the other thing with storage, which is again a great feature in Windows Server 2016 and now coming into VMM, is cross policies. So in 2012 Hyper-V, we got cross policies per VHD. So you can go into your Hyper-V manager, you can drill down to advanced features and pick your hard drive, virtual hard drive, and you can say that this drive can have a max of 50 IOPS and a minimum of 25 IOPS, right? So that's what you can set it. But the problem with that setup was that it's based on each individual hard drive, virtual hard drive, which means there is no centralized traffic cop. So if you've got 10 hosts with 10 VMs on each of them, you've got 100 VMs running, right? And they're talking to the backend storage. And you've gone in and set a minimum IOPS, right? The Hyper-V host has no way of fulfilling that if the backend storage doesn't deliver, right? It can have that minimum IOPS setting, but it can't deliver it, right? It can throttle it to the maximum one, but it can't keep up with the minimum one. So now we have the centralized traffic cop. So built into Windows Server, managed by VMM, you now have these cross policies, and you can also do monitoring. So this is another really cool thing, right? So you can actually go into PowerShell and you can get report in real time on what storage IOPS is each of your virtual machines using. So you can get nice reports and see that, right? And that's something that we as IT professionals haven't really had, unless you've got it on your SAN or something, you can go in and look there. But as far as the native platform, we haven't really had an easy way to see, hey, this SQL VM, it uses 12,000 IOPS. This one over here, it uses a lot less. This Exchange server uses this much IOPS on average, right? We haven't had an easy way to do that. Now you can see that and you can plan accordingly. So we can create these cross policies that you then associate with your storage arrays. So here we got 3 different policies, and then we got 4 different virtual hard drives. And in the end, each virtual hard drive picks a single one, depending on the priority order you've set up, right? So you don't want to make this too complicated. But it is dead easy to set up these policies. They get applied very, very quickly. So if you change the policy on a virtual hard drive, it takes a second or something, and then its load drops down. So here I am in VMM. I'm creating a storage quas policy. I give it a name. I give it a description, right, so that any other administrator who comes after me actually understands what that policy is doing. And then I go in and set the settings themselves to control the load. Notice that I can pick the megabytes per second there as well. And there you have the 2 types of policies. So you can have one, I'll just finish this, and then it attaches it to a particular storage array, and the IOPS size is always 8 kilobytes, so they haven't changed that. They have a drop-down list, but you can still only select 8, so that's it. So that's then been applied, and now any virtual machine is covered by that. So you can create 2 types of policies. So you can create an aggregate policy, where I say to this department in my business, you guys have 10 VMs running on my infrastructure. In aggregate, you guys can use 10,000 IOPS, right? That's the minimum you get, and you get 20,000 is your maximum, right? And that, I don't care which one of those VMs uses up more or less of that IOPS performance. that's what you've got in aggregate across all those VMs. And then you have the other one where you apply it to each individual drive, right? And that would be more in a hosting scenario or something. Somebody's paid for 1,000 IOPS per disk, and they get 1,000 IOPS per disk, and whatever new disks they created, they each get 1,000 IOPS. All right, any questions on any of that? Yes? No, you could apply the same policy twice, right?
Yeah,
so,
but would that mean they're a part of that same group? Or
no, you can apply it to this group and then to that group.
At what level does it get applied? To the tenant level? Or?
In the end, it gets applied on a per VHD level, right? So, but you in VMM, you associate it with the storage array, right? Whether that's and that's a good question. Actually, I should point that out here. So in VMM today, you can only associate a storage quos policy with a scale-out file server or a storage spaces direct array, right? Or how VMM sees storage. In Windows Server 2016 plain vanilla, you can also put them in front of SANs, right? They haven't put that into VMM yet. I'm sure it's coming.
So with that then, how does it determine which one's Department A, which one's Department B, which service and how to...
Right, so when you create a VM, you pick the policy.
Yeah. But if you're just picking the same policy on all...
If you're picking the same policy on all of them. Yes, no, you're right, sorry, my fault. Yes, absolutely, yes. You have to create two policies, one for each department, right, with the same settings in it. Yeah, absolutely. Okay, so here is me creating a storage spaces direct cluster in VMM. So I give it a name, I give it a file server name, I give it an IP address, and I pick my storage attached directly to each cluster node. And I've got blank disks now attached to these machines that it's going to pick up. And I could do this as a physical deployment as well there. Add in my computer names, in this case two hosts, and it adds that in. That takes a little bit of time, so again I videoed it because it's quicker. I then create a pool, add in my drives, and notice here, now I have the pool, right? And it says it's got 4 disks in it, but I've only got 2 nodes in the cluster, which means that now when I create my file share, I can't pick anything lower than failures to tolerate 2. So in the GUI, you have to have 3 or more nodes to create storage spaces direct, because it doesn't accept anything lower than 2 failures, which means you have to have 3 nodes. But in PowerShell, I can simply go in, change that number to 1, and there's my file share. This is a bug in the RTM version. And I did try to upgrade my demo environment to update rollup 2, which was released on the 24th of January, but it broke the demo environment, so I rolled it back. It still sees the storage, right? But it actually reports it as 0 gigabytes, so they fixed that. So now I'm attaching that file share to a cluster, and here you can see it does actually pick up the size, in this case 100 gigabytes. All right, any questions on any of that? So that's Storage Spaces Direct. I've been writing articles, because I write for computer magazines and sites on the internet quite frequently. I've been writing about Storage Spaces Direct quite a lot, and I think this is going to be the default storage option, unless you've already got a SAN, obviously, then you keep using your SAN, right? But if you're setting up new servers and you don't have storage to apply to them, I think Storage Spaces Direct for Hyper-V is going to be the way forward. I think it's an awesome technology. Yep.
When, like, say you expand a cluster,
Uh-huh.
very easily...
Another great point, right? So in Storage Spaces, 2012 R2, and of course it exists in now as well. You can do storage spaces with shared SAS disk trays, etc. in 2016 as well. Adding storage to that is really difficult, right? Because it's got these columns and it's all set up, and you try to add more storage, you've got to redo all of that. It gets very, very messy, right? So the recommendation was always, if you're setting up storage spaces, 2012 R2, determine how much you need up front and then buy that and put that in with a bit of extra margin so you can grow into it. Okay, smiling, right? Storage Spaces Direct have done this much, much better. So you start off with 4 nodes so that you've got your mirroring and your parity together. 6 months down the track, bugger, we're growing, we need more VMs, we've got to have some space to store them. You just buy a 5th node. Plug it into the cluster, it will automatically pick up the drives in the new node, it will add them into the pool, and it'll go, great, I got more storage, and it'll just fill up the extra storage space and move everything out. So they've automated a lot, right? Yep.
And what about disparity in capacities?
So you want to, again, so just like with storage spaces, you want to have spare capacity so that if a disk fails, it can automatically rebuild.
What about different members of the cluster having different capacity amounts?
So it balances that automatically.
So it will utilize as much of
Yeah, now obviously in a production scenario, you want to make sure that you buy your host with the same, right? You don't want to go, oh, I'm going to buy a big beefy server with lots of storage and all these other ones have little storage. That's not, no, fair enough. But the concept is because you can add nodes so easily and just scale out that way to add more storage and more capacity, you want to have like a cookie cutter approach, right? So this is my standard storage server. If you go, heck, we need 2 of them, you just buy 2 of them and plug them in, right? Don't buy one and then say, oh, we'll take all those disks and plug them into this one, right? That's not a good idea. All right, yeah. Yeah, I have plenty of space in those servers to add more storage. Yes, absolutely, that's another option. Now again, in a production scenario where TAFE isn't paying for the hardware, so you actually have some real budget. No, I shouldn't say that, they were very nice to us. You would want to buy, you know, your storage servers with plenty of disks already plugged in, right? So you want to fill them up if you can, right? And then add more servers when you need to, but it all depends, yep.
The problem with that is what I can buy a year ago, I could get 1 terabyte drives,
Yep.
20 of them.
Yep.
Nowadays, I can get 4 terabyte drives.
Yep, absolutely.
So I'm not going to buy
You're not going to fill them up?
terabyte drives,
Yep.
and I'm not going to buy only a quarter of them.
No.
I'm going to go, all right, I can fit 15 in, I'll put 15 in.
Yeah.
Not. So what you're saying doesn't make sense. That means what you're saying is I'm not going to mix in the old and the new.
No, I'm not saying that. So first of all, yes, if you have spare slots in your servers and you want to add more capacity, you can simply buy more hard drives and more SSDs and plug them in, right? And just like I said with the other scenario, you add more servers, it will then pick that up. Hey, you've added more storage, let's add that to the pool. Now I grow the pool, now you have more storage space, right? But alternatively, you could buy more servers as well, right? So you have the flexibility to do either. I'm not saying you have to do one or the other. Does that make sense? Thank you.
Does it when you add more drives,
Yep.
automatically increase the column size, or do you have to recreate volumes?
That'll be a great question for Stefan. 5 o'clock. I think it does, right? I think it does. From all the demonstrations I've seen and everything I've read up about storage spaces in my own testing, it does a lot more automatically than the old storage spaces did, right? They really tried to make it easy. So, okay, headline features. So shielded virtual machines. How many people have heard of shielded virtual machines? You get to exercise your hands. So that's about 3/4 of the room. Those of you who've missed the memo from Microsoft, they now have a feature that is unique to Hyper-V, right? And the reason they have that, of course, is because they run Azure, right? And they really want this feature. So the whole point here is that today a host administrator is God. If you're running your domain controllers on Hyper-V or VMware or any other virtualization platform, your host administrators can go into those drives and look inside of them. They can attach a debugger to the running memory of your virtual machines and look at the secrets in that memory, right? They can do all sorts of things because they live outside or on top of, or however you want to describe it, the virtual machine. So they have full access to them, right? They can take a copy of that virtual hard drive with them home, run it on the Hyper-V host at home, and do whatever else they want to do to that drive, and do you know, an offline attack against the Active Directory database or whatever they want to do. Concept with shielded virtual machines is that there is now a technology to stop this from happening. I can block the host administrator from having access to my machines. They can still run my virtual machines, and they can do a denial of service, right? So they can turn off the virtual machine, of course, right? But they can also turn off the physical server. So that's the power they've got, but they can't access the virtual machine. So, shielded virtual machines. There's a whole bunch of prerequisites to get this running. I should point out as well that I'm trying to provide as much value as possible to you guys from this session. So setting up shielded virtual machine, the infrastructure to get that working in VMM was a multi-day process for me. I made some mistakes along the way. I followed the documentation, and then I made some other mistakes. I have recorded all of that in a video that I've got on my blog. I'll give you the URL towards the end. So if you want to see all the steps that I took to get it up and running in VMM, you can watch that there. I've also got a video on setting up software-defined networking and all the steps you have to go through there. Obviously, I don't have time to go through that in this session, but it is available for free on my blog. You can go there and look. All right, so shielded virtual machines. So we take a virtual hard drive, a VHDX file with an operating system on it. We run it through a template disk wizard, and we end up with a signed VHDX, right? So the way Microsoft envisages this, if I'm a separate company to you, and I'm going to host my VMs with you, like Azure or Amazon, whatever, I could create this drive myself and then upload it to you. Or alternatively, you could provide it for me. If I trust you that much, right, you could provide a signed disk for me. Then I go into the shielding data file wizard, which is a GUI, and record all the secrets for my virtual machine. So the administrator username and password, RDP certificates, and any other secrets going into that machine that I don't want the host administrators to see. I then give them the PDK file, and in case of VMM, they put that into the VMM library, and I can now deploy a virtual machine from there. So this is creating a new virtual machine, and then off it runs on the infrastructure. So behind the scenes, how does this work? So we've got a Windows Server 2016 over here, Hyper-V host, and we have a host guardian server or service server. Now, in a production scenario, you want to have 3 of these, and they should run on physical hardware. They should not be virtual machines. Now, if you're spinning this up in a lab and you're playing around, there is actually service templates for VMM to deploy these as virtual machines, right? But that is not recommended for a production scenario. They should be on physical hardware. They need TPM 1.2 chips. Whereas if you want to go the full hog with your Hyper-V host, they need the new TPM 2.0 chip. I thought it would be difficult to get those, but if you tell your rep, at least if you're buying from Dell, I'm not spruiking Dell in any way, but that's what we happen to do. If you just tell them when you want TPM 2.0 chips, they put them in. They didn't seem to be particularly expensive. So the user has created a shielded VM using the signed VHDX and shielding data file like we saw on the previous screen. The host then goes to the host guardian service. This is a separate Active Directory forest. Or if you have an existing Bastion forest, you can put them in there, but generally this would be a totally separate forest. It then goes and says, am I healthy? Right? So it's literally asking the HDS server, hey, show me a mirror and tell me if I'm okay. Right? And it goes through some tests and makes sure, yep, you are the server that is allowed to be part of this guarded fabric. You have the right certificates. You may or may not, depending on how you set this up, have a code integrity policy that guarantees what executables can run on that Hyper-V host. And if that's all okay, we then say, yep, that's okay. You can get this attestation certificate. You're an okay host. And then it goes, okay, this particular VM here, VM1 that I'm trying to boot, I need the keys to unlock that. Goes back to the host guardian service, which sends back the key. So that could be a BitLocker decryption key for the hard drive, and then it starts up the VM. Any questions on that process? Right. It then unlocks the drive and starts the VM. You can also shield an existing VM, right? So you've got to remember here that when I teach my students about shielded virtual machines, they get very excited because it sounds like you've got this VM, then it's like impenetrable, right? It's like the Iron Man of a VM, right? You've got this armor on it, but that's not what this is about. The threat we're looking to protect against here is an attack from the host administrators, right? If you run Internet Explorer, well, this is Microsoft Conference. If you run Google Chrome inside of that VM and you go to a malicious website, right, and you download some malware, that VM is just as susceptible as any other VM to be infected by malware, right? if you leave your ports open and a hacker can get into it from the internet, they can still install their hacker tools on that machine, right? So it's not shielded in the sense that it's more secure. It's just shielded against the host administrators. So we take an existing virtual machine that is running, because obviously, right, you're not going to recreate all your virtual machines just to get them shielded, right? We have a shielding utility VHDX. You go into VMM and you tell it about this particular shielding utility. You've got to run that PowerShell commandlet there to set this up for an existing virtual machine. And then you take your regular VM together with PDK file again, that's the shielding data file. Now that shielding data file for an existing VM cannot be the same as for a new VM. So if you have a tenant that you expect to create new VMs as well as shield their existing VMs, they need to create 2 PDK files with the information in it. So then we end up with a shielded virtual machine again. So here is, and this takes a while, so here's creating a shielded virtual machine in VMM. So I've got some shielding data files that I've added into my library. In my VHDs, I have a signed image that I have created, right? And it tells me a few things about it here. And then I have a VM template for a shielded virtual machine, in this case running Windows Server 2016 Data Center Edition. So those are the bits that I need to have in place, right? And once I have that in place, here's the settings, right? So that's pointing to that external forest with the host guardian services in it. I can then go in and create a virtual machine, and the process is extremely similar to how you create a virtual machine today in VMM. There's a couple of little differences. I pick my shielded template, give the machine an identity, and you'll notice here in a minute that I don't get asked for the administrator password and those details because I picked those up from the shielding data file. Okay. Of course, configuring the hardware is exactly the same as everything else in VMM. And the other thing you need to think about here, if you're looking to implement shielded virtual machines, you want to make sure that you think this through, because if you're hosting this VM with somebody else and something goes wrong, they can't help you because the machine is shielded, so they can't get to it, right? So again, I get some ratings here on this, which host is going to run it. If one of these hosts were not attested, it would have 0 stars, then I wouldn't be able to run the virtual machine on it. Right? In this case, they're both attested. Give it a computer name, and I think that's about it. And then it deploys it, and that takes a little bit of time. So that is a question that often comes up around, yeah, sorry. No, it does encrypt the traffic. So again, as a host administrator, you can't listen in on the wire, right? All the live migration traffic is encrypted. The official guidance from Microsoft that there's about a 5% overhead using shielded virtual machines. So if you have a host that can run 20 unshielded virtual machines, they say you can run about 19 shielded virtual machines on it. So that's If it is not attested, it will need to go to the host guardian service and say, yep, I'm here. So you can't live migrate to a host that isn't attested. It has to be part of the guarded fabric, right? So the concept here is that as tenant, I will say, this is the fabric that I allow this VM to run on. And that's why if a host administrator, he can always shut down the VM and export it. If he takes a copy of that VM home and tries to run it on his laptop, the VM won't boot because it'll say, well, this laptop is not talking to the host guardian service, it's not attested, it's not okay. Here I go in and I look at the Connect and notice that Connect via console is blacked out. Now, as a sideline, there's actually 2 flavors of this, right? So there's the full shielded virtual machine, which is what we're looking at here, right? No host administrator access whatsoever. Now, you may also have a scenario where for compliance reasons, you need your virtual machines to be encrypted at all times, encrypted at rest and encrypted in transit when they're live migrated between hosts, right? If that's your requirement, you need to tick a box on a compliance rule of some kind. you can use encryption supported. Right? And I suspect that that's probably mostly what's going to happen in enterprises when they start off with this, right? Is they're going to go with that mode because that still allows console access, right? Nobody asked me, but of course PowerShell Direct doesn't work on a shielded virtual machine either, right? Whereas if you have encryption supported, you can run PowerShell Direct as well. And then, of course, if I go into properties here, I can see that this machine is shielded, who owns the key, where did I get that Guardian from, etc. All right, any questions on any of that? See how I'm going for time. 3:30, ooh, 15 minutes left. I think we're all right. Let's keep going. Storage replica. I was considering telling you a Nat joke from Sweden, but it would probably get lost in translation. Feel free to groan. How many people have heard of storage replica in Windows Server 2016? So I get a few hands, or maybe less than half. This is the final piece, right? So I said that storage spaces was Microsoft's way of going after your SANs, right? So you didn't have to buy SANs anymore. The one feature missing in 2012 R2 was I've got a storage spaces in one data center, I've got a storage spaces in another data center. How do I synchronize the traffic between them for disaster recovery purposes, right? So if you have a SAN in that end and you have a SAN from the same vendor in the other end and you pay the extra license to do SAN replication, you can get that data replicated to that SAN and vice versa, right? But it's very expensive generally. That's an extra sort of on top of to buy the expensive SAN in the first place. So storage replica is Microsoft's answer. So as long as you got Windows Server 2016 data center in each location, it will synchronize the traffic, it will block replicate data from one location to another. And as you can see here, it doesn't depend on the storage. So you can have a SAN in one end, you can have storage spaces direct in the other end. You could have local storage in the other end. It doesn't matter, right? As long as it's block storage and the blocks are the same size. So if you've got 512 bytes blocks here, you've got to have 512 bytes blocks there. If you've got the advanced new ones, the 4 kilobyte blocks there, you've got to have 4 kilobyte blocks there because it does block replication. But other than that, it can replicate from anything to anything. So there is support in VMM for storage replica, but it's not huge. So we're missing some things today, right? Your source and destination must be managed by the same VMM server. And that could be challenging going between two data centers. You must be running on Data Center Edition. You can only do synchronous replication. So storage replica itself does asynchronous replication as well, which can go much longer distances. You can only manage it with PowerShell. You need those ports open. And there's no right ordering and consistency groups, which is all about SQL Server guys, right? They like that. So final feature here is software-defined networking. So how many people attended the session yesterday afternoon on software-defined networking? So that's about a third of the group. This is a really big thing in Windows Server 2016. So the internet is big. DNS jokes take a long time. All right, so out of the people who put up their hand and have the VMM in production, how many of you have done Hyper-V network virtualization? So I get like 3 or 4 or 5, 6, 7 hands. Okay, network virtualization came out in 2012. It was built on Microsoft standards, NVGRE protocol, and unfortunately, you're going to have to do it all again. Right? If you actually did this and you want to move forward to Windows Server 16, you're going to have to redo all of that work. I'm really sorry, but that's how it is. The little silver lining on that cloud is that it is a lot better in Server 16, right? So here's your SDN components. I don't have time to go into details of these, but this is all built into Windows Server. So the way you deploy this in VMM is that these run as VMs. There's a link. And there's 3 ways of deploying this. You've got a VMM Express script that sets it all up in VMM for you, provided you have enough infrastructure. Or you can just go into the VMM console with your service templates and grab it from there. And then set it up manually step by step. So here's the networking stack in 2012 R2. VMM kept track of everything. 2016, we add the network controller in the middle, and it keeps track of all the virtual networks and everything else, and your software load balancer in your gateway, and then VMM just creates the virtual networks and put them out. All right, so in 2012 R2, you had to have a hardware load balancer if you wanted to load balance your incoming traffic, right, or futz around with the network, the NLB in Windows Server, which isn't that great. So now you simply add one or more of these SLB muxes, multiplexers, and they do the software load balancing on the way in. If you need a gateway, so you've got a tenant network here, and it needs to connect back to on-premises or another data center, or it needs to connect to somewhere else, you need this gateway. So in VMM 2012 R2, you had to have physical boxes with VMs on top of it that did guest clustering for high availability, and it was active-passive. See one of those in gray. So now, of course, that is much, much better because you just spin up more gateway nodes as you need to on your network. So here's the topology, and once I've built this out, I hope this makes it a little bit clearer for you. It took me a few goes to get this. So we got 4 hosts. They got 2 physical NICs in each host. We lay down a management network at the bottom. And if you go to TechNet documentation, you'll see the finished slide when this is finished building. We then add in some VLANs here for your management. Then you add in the network controller VMs. So they run on the hosts side by side with your production VMs. Then I add in my provider network and a transit network that goes off cloud if I need traffic to go outside. And once all that is in place, I can now create my virtual networks. Right? And in this case, we have a blue network and a green network. They're using the same IP address ranges. They've got 3 VMs inside of each of them, but they can't see each other because they're on a virtualized network. Right? And then we clean that up by getting rid of the host. Then we can then add in the software load balancers. So at this stage, if that's all you need, you don't need to add anything else. If you want software load balancing, you can add that in, and you can also add in the gateways if you need that to go outside. And you spin up as many of those. These are modern high availability, right? So the network controllers are all active. You got 3 of them in a production scenario. They're all active. They're all doing the network controlling. And if one of them fails, it will automatically spin up another one, and they can talk to each other, and they know what's going on. So you don't need to manage those. So that's the full scenario there. So here we have a service template for a network controller. This is a 3-node one. It's spinning up 3 VMs, and that's the information I pop in there. I have a demo in there, a live demo if we get to that. And here's the software load balancer template as well. So let's talk about some real-world issues around VMM and networking. So one of the best things they fixed in 2016 is that if in earlier versions, if you had a Hyper-V host with a virtual switch configured on it already, and then you tried to push out a logical switch onto that host, it basically destroyed this one, and then all the VMs that were running on that machine, they lost connectivity. Got real messy, right? So they fixed that now, and it keeps on working. You still need, of course, to create logical switches inside of VMM for everything, because it relies on that for everything else. If you have just a bunch of Windows Server 2016 and you go into Hyper-V hosts and you go into the virtual switch, there's an Azure VFP extension, switch extension in there. If you tick that box and you haven't done anything else, all your VMs will now lose network connectivity because you haven't actually configured the software-defined networking yet, right? So you need to, don't just tick that, you need to have that configured for you. As I said, 2012 R2 relied on Microsoft's NVGRE. Technically, that was a great protocol, but the rest of the world has moved with VXLAN because that's what VMware uses, and the hardware vendors are supporting VXLAN much more than they're supporting NVGRE. And you can actually choose NVGRE in Windows Server 2016 as well. It's a one-time choice. You set up your new fabric, go with NVGRE if you want to. But the problem is there's not going to be any more development on there. And even if you have some 2012 R2 clusters and some 2016 clusters, and you choose NVGRE for your 16 clusters, they still can't talk to each other because they're using a separate way of storing the information, right? So in WMI in 2012 R2, and in 16 we got this Open vSwitch database management protocol. So I've always looked at SDN as, oh yeah, that's great technology. Next time I work on a data center with 140 hosts, I'm definitely going to look at SDN, right? That's going to be the way to go. For anything smaller, never worry about it. But what I realized is, over the last couple of years as I've been looking into SDN, it's actually great. One of the biggest benefits is if you set up software-defined networking in your data center, right? And you have to talk to the networking guys to get it working. Once it's working, you never, ever, ever need to talk to them again. Because when you deploy virtual machines, you just deploy them into virtual networks, and they never know. They run on top of their physical network, so they never need to worry about it, right? So software-defined networking is great, and it also gives you some fantastic security features. This is for your reference. You can download these slides, of course. They're already available up there. And this is what's missing in the different versions here. So this is 2012 R2 software-defined networking, and this is 2016, right? And that's Microsoft Azure Stack, and you can see things missing. There's a few things that you can't do in the GUI. So for those of you who played with Azure, ACLs is the same as a network security group in Azure. You have to use PowerShell in VMM to do that. Same thing if you're managing the load balancer, the software load balancer. The two things that is in SDN today but not in VMM is user-defined routing. The guys yesterday talked a fair bit about that. You're putting your virtual appliance in to do scanning of your traffic. And port mirroring. Port mirroring is much better. You can mirror from several machines. You can filter the information you want and then pop it into this virtual machine where you're running Wireshark or something to see what's going on. I was going to demo software-defined networking, but I have literally 3 minutes to go. So I'll go through these, and then if we have time, if there are no more questions. So these are the sessions here at Ignite that cover this sort of stuff that you want to grab. I don't have the links here yet, of course, but they should be available on Channel 9 by next week. Here's some good recordings from Ignite in the US at the end of last year. Again, you can download the slides. These links are all available on my blog as well, on the page that I'm going to show you in a second. So if you don't want to, you don't have to take photos. And here's some resource slides. I've got 3 different resource slides here with documentation and information on VMM and how to set all this up. And there's resources number 2. All the phones are going. Okay, and there's resource slide number 3. So one of the interesting things about the SDN, because this SDN stack is essentially Azure, right? They've just taken the stuff they're running in Azure and they plonked it into Windows Server 2016. They have much better troubleshooting, right? It's a much more complete ecosystem already. So these links here talk about the workflow for you doing your troubleshooting. It's got tools, specific PowerShell commandlets to troubleshoot all this stuff to make sure your SDN infrastructure is working as it should. Here's some more links for you that you have seen 100 times before. Please, please, please complete your session evaluation. I would really appreciate it. If you put any comments in, I promise I'll read every single one. And wristband looks ugly orange. You get them right outside of here. And so there's my information, right? So there's my email address. If you want to ask me anything about anything I've spoken about today or anything else, you can try to hit me up on Twitter, but I'm not a frequent Twitterer. There's my website, and that link there, so that link there has the setup video for Shielded Virtual Machines, setup video for SDN, and all the demo videos and all the resource links. Thank you very much.